Now, just quickly, in this video, we're going to go through and review bearings because quite a few of you stated that you needed to work on bearings, and I know that we went through it pretty quick and we gave you 20 minutes at the end of the class. So I'm going to go through that. The second thing is I want to review sine rule and the cosine rule, and also I'm going to introduce to you just towards the end finding the area of a triangle, a non-right angled triangle, because we know that the area of a triangle is a half base times height. We would have done that before. This is for non-right angled triangle, and then you should be able to have a practice at the questions. It's a fairly straightforward process. It's plugging numbers into a formula, very easy, and once again it uses the whole big A, big B, big C notation that you've seen from the sine and the cosine rule. So you'll find that very straightforward. Okay, now first of all, just quickly, I wanted to just make a bit of a note that, don't know why that's doing that, but okay, just wanted to make a bit of a note that true bearing is clockwise always from due north. So due north, if we're told that the true bearing equivalent to north 75 degrees west means that we're starting here and we're going this way 75 degrees, so this angle must be 15 degrees. Now, if I'm starting from north and I'm going clockwise, that's what a true bearing is. We are always starting from this position here, and we're going clockwise. Oh, we've gone 90, we've gone 180, we've gone 270, and we've finally gone 270 plus 15 degrees. So the true bearing is 270 plus 15, which is equal to 285 degrees. So that's all the true bearing is. It's a true bearing from this position here, which is north. Okay, so if I had this, and let's just say this was 40 degrees here, then going from this point here to this point here has a true bearing of, goes around 90, goes around another 40. So this is a true bearing of 140 degrees true, we might say. Sorry, 130 degrees true. That's what this angle here represents. Yes, it's 40 degrees to the horizontal, but it's 130 degrees true. Okay, we'll do another question though. The direction due west when expressed as a true bearing is, well, due west is over here. Over here. And we've got to start from here and go 90, 180 to 270 degrees. So I hope that most of you got the answer was E, 270 degrees. Are there any questions so far? Pretty straightforward, I hope. Now let's go ahead and do question 6. Now it says here the value of x correct to one decimal place. If you're watching this for the first time, you might want to pause now. But I've made a bit of a note here. We have two angles, and we have the sides which are opposite of those angles. That's a big hint that we have to use the sine rule. For the cosine rule, if I have got, now the cosine rule can be used to find three lengths, or if we've got three lengths, if I know what A, B and C are, I can use the cosine rule to find an internal angle. However, if I know two lengths, if I know A and B, but I do not have the angle between them, then I cannot use the cosine rule. We cannot use the cosine rule unless we have the angle between the two lengths. So if that's the case, it's usually a hint that, okay, we can't use the cosine rule. If you go ahead and plug your numbers into the cosine rule, you're going to have two unknowns. So the hint is you need to know when to use the sine rule and the cosine rule. The cosine rule is when we have three side lengths or two side lengths and the angle between them. The sine rule, however, is when we have two sides and an angle or two angles and a side, and you need to know what's opposite. So for example, over here, I'm just going to say that this is, we're going to call this big A, this side big A, this side big B, and this side this angle big A, B and C. That means that this side is A, this side is B, and this side is C. And then we're going to use a sine rule. Now remember, we don't need to know side C, so we don't use that part of the sine rule. The sine rule states that little a on the sine of a, so little a on the sine of a is equal to little b on the sine of b, and so on. So that's the first thing you're going to do, set up the triangle. Now you've set up the triangle, let's fill it in. Well, a is actually x, so we're going to put that in. X is equal to, and the angle of a is 109 degrees. Little b is 3.6, and sine of b is sine of 47 degrees. Now you can see here that we've clearly got just the one unknown. If you ever get two unknowns in a sine rule, it's probably a fair chance that you have to use the cosine rule. Okay, so we've got to now solve for x. Now we can go ahead and put that in our calculators and do that. But of course, in your test, we're just going to give you a scientific calculator because I'd like you to be able to do the algebra. The algebra is we want to get x by itself. So what do I have to do to both sides to get rid of this sine 109? It's divided by at the moment. So I'm going to times by. So I'm going to just skip a step here and we're going to say that 3.6 times sine of 109 degrees over sine of 47 degrees. And if you put that in your calculator, scientific or CAS, you should be able to get, what was the answer? 4.7? That's 4.7. Answer's 4.7. Thank you. All right, now I'm not going to do that calculation because you've already done it for me. Thank you. So far, we've looked at the sine rule, and I think that, are we okay with that, the sine rule? Good. And if you can do the sine rule, you should be able to do the cosine rule. And this is an example of the cosine rule. Now, not maybe straight away. A ship travels due east from A to B for 9 kilometres. So we're going across 9 kilometres and then a true bearing of 130 degrees. What does that mean? It means that we've got, that's 40 degrees. And we've actually can form a right-angled triangle, if you like. We can use SOHCAHTOA. We can't use SOHCAHTOA if it's not a right-angled triangle. So, and we're then going 7 kilometres. 7 kilometres. No, it's not. That's 7 kilometres. Okay, so it just says label all the diagrams. That's 9, that's 7, that's 40 degrees with any angles. That's all you had to do.
Is that inside 140?
Yes, that's correct. So,
Wouldn't the inside be 140?
just wait a second. Just wait a second. This is 140 degrees. 130 is, we're talking about a bearing. The bearing is due north, from due north. So if I start from here and I go there, then we know that that's 90 degrees, don't we? And then we know that 90 degrees plus the 40 degrees is going to give me a true bearing of 130 degrees true. Okay? So we'll just have to, some of us might just have to revise our bearings. It's always from north. So, yes, that's right, because this angle here is 140 because we know that the angle of a straight line is 180 degrees. So what we've actually could construct is a triangle here. And that triangle we're now going to use for the next question. So the next question is, how far south is the ship from the starting point? Well, what that is we're trying to find the length of this line here. And yes, you can use SOHCAHTOA because it is a right-angled triangle. So what we've got is we've got a pretty simple triangle, which is 7. And this angle here is 40 degrees. This angle here is 40 degrees. It is a right angle, and we want to find, if you like, we might call that x. So the angle south, we've got SOHCAHTOA. We're using what are we using? We're using sine. We could use sine, or what could we use? What's this angle? That's 50 degrees. Or you could use, if you did cos of 50 degrees is equal to x over 7, you could do it that way. Or alternatively, you can say that sine 40 degrees is equal to x over 7. Either method, you will still get the same answer. So therefore, x was equal to either, let's just say I'm going to use the sine 7 times sine of 40. And what was the answer correct? What was that, sorry? 4 point...
Yeah. The decimal was 4.49.
4.49, which, yes, is approximately 4 kilometres if it's to the nearest kilometre. Okay, good. And the last one is, we've got to use how far is the ship from its starting point. So I'm just going to go back up here and I'm going to go do something. And we've got this time, we've got to ask ourselves, what do we have? Do we use the sine or the cosine rule? We've got 2 lengths, which we know those, and we've got the angle between them. So what rule are we using, the sine or the cosine? We're using the cosine rule. So I'm going to label those, and I might say that the cosine rule is, what was it? Isn't it a squared? Oops, no, I don't want that. I want this one. I'm going to say that a squared is equal to b squared plus c squared minus 2bc cos a. Is that right? Okay, good. Now, as long as you make A, the angle A is the one you know, then you can use that formula. Be careful though, you need to make sure that you know what that angle is. So, or label the triangle accordingly. So, this triangle, I'm going to just draw it over here, 140 degrees here, I'm going to make that side or angle A. So that's angle A. I'm just going to make that angle B and angle C. And once again, so that means we don't know what little a is. We don't give a hoot about that, do we? That's the one we've got to find. We do know that little b is equal to 9 kilometres. And we know that little c is equal to 7 kilometres. And now we can apply the cosine rule. So I'm going to do that up here. So let's write that out. A squared is what we're trying to find. A squared is that distance we're trying to find. Is equal to b squared, which is 9 squared, plus c squared, which is 7 squared, minus 2 times b times c, which is 7 times 9, times cos of 140 degrees. Now, what did you get when you added those up? I'm not going to do it. What did you get? What is a squared? What did you work it out to be?
I'm not sure.
Do I have to do this myself?
I got 227.12.
Okay, let's just check out what we've got. So, we've got 9 squared plus 7 squared. Be careful with use of brackets and things. I now have to subtract, and I'm going to open a bracket up. And I'm going to say that I'm going to put in the brackets, it's all subtracted away. So I've opened up a bracket, I've got the negative out the front, so I'm not going to make any mistakes there. 2 times 7 times 9 times, be careful if you're not in degrees mode, I'm going to go to trig, and I'm just going to go cos of 140, press the pi button, choose degrees, and that gives me my answer, 226.52. Well, it's not my answer though, is it? It's my answer for a squared. That's correct. So, how far is it? We're not caring about a squared, we want a. So that therefore we can say that the distance it's travelled is the square root of 226.52, which, if I do the square root of, what is it, control, what is it, where's the answer? Let's just do that. 15.05. Okay, is that making sense so far? All right, so 15.05, I think it was kilometres, wasn't it? All right, so hopefully, so far you're okay with that. If you're okay with the sine rule, you should be okay with the cosine rule. So therefore, we've done 15.05 kilometres. And now I'm going to just take you through the last one, which was this. This time, I wanted to introduce to you briefly the area of a triangle, but first of all, we're going to use the cosine rule again. Now, we've labelled the triangles big A, big B, big C, and I've already done this, started it off for you. So once again, we've got 1, 2, 3 sides. We want to find the angle of A, so we want to find this one. So let's write it out. Let's write out what we've got. We've got A squared is equal to B squared plus C squared minus 2BC cos A. Let's fill it out. We've got 43 squared is equal to 58 squared plus 29 squared minus, open bracket, 2 times 58 times 29, and then we've got times cos A. Now, if I were you, if you had a CAS calculator, you could do your solve and you could do that, or we could just evaluate what it is. 48 squared, let's get this stuff to the other side. Let's just say that I've got 2 times 58 times 29 times cos of A is equal to 58 squared plus 29 squared minus 43 squared. Now, I'm just going to stop there and we're going to evaluate what each side is, just to make things a bit simpler. So, let's do 2 times 58 times 29, and that is equal to 3,364. So I've got, let's replace that with that. Shh. Hang on, this background noise, when you're trying to watch a video, all I'll hear is you gas bagging. Now, let's try and let's simplify the right-hand side. So I've got 58 squared plus 29 squared minus, 43 squared. Is that right? 43 squared? Yes. Minus 43 squared. 2,356. Now, that's looking a bit better, isn't it? Now what you can do is just some basic rearranging now. And we're going to say that cos of A is equal to 2,356 over 3,364. Okay? And, of course, we want to find the angle, so we need to use the inverse cos, which you need to do for your calculator. You can use either your scientific, 2,356 over 3,364, and that is, and be careful, it needs to be, if your calculator's not in degree mode, if you have a CAS calculator, then it needs to be in degree mode. Now, for year 12 and year 11, you'll want your calculator in radians. We're in degree mode just for the time being, so that means that we're going to get the answer we want. If you get some funny looking answer for an angle, like maybe a decimal, then or like a 0.04, it's probably fair to say that you don't have it in the right mode. So let's do trig inverse cos, and we want inverse cos of the fraction 2356 over 3364, and voila, 45.54 degrees. So, therefore, the angle is, what was it? 45.54 degrees. That's okay, all right. Thank you. Correct to 3 decimal places. Yes, thank you. All right, now, before we do finish up today, I just wanted to introduce you to finding the area of a triangle, which is actually the next exercise. And I have no doubt that given you know the sine rule and cosine rule, you'll be able to do this, and you'll be able to do this at home and definitely finish off these questions over the weekend. I certainly wouldn't expect you to do it tonight. Area is a half little a, little b times sine c. That's your formula. So what we can do is we can find the area of any triangle if we know two sides and the angle between them. Be careful though, you need to know the angle between those two sides. So what we have to do then, notice that we're looking at, we need the angle sine C. So what we need to do then is, do you think then that we would use, we've just found this angle here. It says hence. Hence means let's find the area given what you've just done. So I'm going to draw that. Now, given that this formula is telling me sine C, I'm going to redraw this triangle out, and I'm not going to label it A, B, and C anymore. Okay? Let's do something like this. I'm going to say that it's still 58 metres. We've just found this angle to be 44 degrees. And this length here is 43 metres. And this length here is 29 metres. Now, I know that I have two lengths, and I have the angle between them, which I've just found. Now, if you wanted to find the other ones, that's fine, but rather than me use, the trick to it is, because I've been given ABC, you might be inclined to use it again. But I'm going to tell you that in this formula, we need sine of C, so why don't you just make this side C? Okay, and then I can just go any way. I can go A, B, C. I can perfectly fine to do that. And let's go ahead and say that this is then for length little b. This here is length little a. And I can go ahead and find the area of that triangle. So the area is equal to 1/2 times little a, which is 29, times little b, which is 58, times sine of the angle between them, which is 45.544 degrees. So really, it's just a simple formula, and it's the same notation as what you've done for the sine and the cosine rule. This is probably the easiest stuff to get now. So we work that out, 1/2 times 29. So I'm going to go 0.5 times 29 times 58 times the sine of the angle between them, which was what? 45.544. And be careful, just in case your calculator wasn't in degree mode, just make sure it is there. And I've got 600.296. Now, given that the question was in what units? Metres? 600.296. It's 0.30, thank you. 30 metres squared. All right. Now, I'm just going to pause this here and just ask how we're going with it. All right, so I'm just going to stop there, and I hope you've learnt something about sine, cosine rule, and area of triangles.